Quite sure what I did to myself here. What's wrong with you guys?
You're missing in the end parentheses, line 52.
Thank you. Okay, next thing I want to talk about are computed properties. And that's different than stored properties. Stored properties simply store their values. Computed properties. I called them public methods. I'm not sure that's quite right because later on they start talking about methods. What's the difference between a computed property and a method? Well, you guys are no help. I'm not either. I really don't have a good answer to that. Methods, remember, they do something. They don't necessarily have to return a value. And the examples they use in the book don't necessarily return a value. But the computed property looks like a property called, they use center of a square, right? Let's see if I can find it here.
It looks like that computer property is more like with a var beginning, all the methods and functions.
Yeah, they're defined differently, but functionality-wise, how are they different? I hate to use the word functionalities when I'm talking about functions and methods, but I don't see a big difference. I was playing around with that homework assignment that I set up for you. I was playing around with that, and then in one of the assignments I said, make a function to do this. And when I was done, I said, that could be a computed property, I think. Because the function actually, the method, the function, returns a value. And if it returns a value, that sounds like a property. Unfortunately, in this case, it returns multiple values. It's an array of values. What denominations do I need to make change? How many quarters, how many dimes, how many nickels? It's an array of values, so it didn't feel quite right for me to make that a property. Maybe it's a feeling thing, but I doubt it. I think it's a little bit more complicated than that, and I haven't figured it out yet. We'll have to see as we gain some experience here what the big difference is between them. So here's a computed property that they have defined, or getting ready to define. I should make my window bigger. It might read a little better. It's not going to help too much. There we go. Here's my variable center. So what I have is this object. And notice they're using multiple definitions. Here's a structure that is a point, and there's John's statement again about, didn't know we could define two variables on the same line. Yeah, you can, but I don't know that I like it necessarily. This kind of gets hidden, doesn't it? I would move it down to the next line. Yes, you have to give it its own var. Big deal. You save 2 characters with a typing. This is a point, an XY point on a Cartesian graph. A size is the size of a rectangle. And then here's their definition of a rectangle. Where does it start? It's 0, 0, at 1, 1, at 73.2.6. Okay, wherever you want it to start. It also has a size, a height and a width. And notice these are embedded inside. That's not inheritance. It's a little different. This is one object that is comprised of other objects inside. That's different than inheritance. Okay. So here we have a size, and then there is a center. Where's the center of my object? Well, the center of my object is actually calculated. And so when you ask for it, it figures out where the x is by taking the beginning times the size divided by 2, and the beginning, and then returning a point. Notice a point is a return value here. But what's bizarre, so that's calculated. What it returns is a point, which is a complex object. It's a structure. My first thought was that a computed property returns a single value. Well, it does, sort of, right? It returns a point, which has 2 values hiding inside it, but it is still a point. What's bizarre about this one, and I haven't been able to come up with too many other examples of why I would want to do this, is I can move the center of the object by setting this property. The getting, that's very similar to a function. That is a function. do this, and return that. That's a function. It's just got a different definition here with the getter. But I could do the same thing with a function. This I can't do with a function. I cannot use a function to change a property that's calculated. But that's really what a computed property is. It's a property that's calculated based on the other things that are inside the class. And that's just a little bizarre to me. But it works out okay. The only thing, what's different is this is actually stored and you can ask for the center. Well, if it was a function and I asked for the center, it would still return a point to me. That's fine. But this setter is what's difficult. At least for me to get my head around. This is where I want it to be. Then we move the origin. If this is where your center is and the square is 2 inches wide, then I move the center, then the beginning of my square has moved, and they demonstrate that. But notice how they define the rectangle with an origin that is a point where the point has 2 values and a size where the size has 2 values. Interesting. Complex. This is what I was talking about before the break, about how data structures, I think, is going to become a little bit bigger part of your life, at least in the assignments I'm dreaming up right now. There's 3-4 different ways. Which reminds me, one of these days I have to share the solutions, that some of the pieces of the solutions that you all have come up with for our first assignment. Because there's little pieces, parts, and just about every one of yours is different that I would like to share, so I might set that aside for Wednesday. Talk about that a little bit. I'm going to have to gather all your playgrounds together someplace so I can show them. All right. Here's the initial square center. What we're getting here is the get. We're using the getter to find the center of this square. And then we're moving it. Here's a new point. Move it from wherever it is. It's probably, since it's 10 by 10, it's probably a 5 by 5. And now we're saying move the center to 15 by 15. Move it, change it. And then it displays it. It displays the information saying that the top of the square, which started at 0, 0, right here, has now been moved to 10, 10. And they have a nice little graphic representation of it coming up here someplace. There we go. We started with this square with a calculated center at 5, 5. But then we forced the center to move here, which moved my square. Why didn't it just move the origin? Depends on the game. This is an object in the game. Maybe I'm interested in the center instead of the origin. Maybe. It's an example. I don't have a whole lot of examples where I want to use a setter to change a computed property. Kind of has a side effect, right? Move my center ends up changing the origin, which it should. Interesting concept. Okay. Here's another one. Calculate somebody's age, and I'm cheating. But it's a computed property, and computed properties, one thing you must recognize is that you can't initialize them. You give them; they must be given a type. Return today minus date of birth. That won't be exactly right, but who knows what we want to do with it. Okay. And then setting it doesn't make a lot of sense. Why would I want to set somebody's age? If I want to change their birth date, that's fine. But if I want to set their age to 23, how do I determine the birth date based on that? Unless I'm assuming their birthday is today, change their date. But why would I need to change it? Because the getter should automatically update. So I had trouble coming up on an example from my notes of another type of object where I would want to use a computed setter.
Couldn't you do this for your validation? Could you use the getter there to do that? I mean, you got the will set and did set coming up, but
could I use this?
Isn't that kind of like a computed property? Maybe not. I don't know. It's just a thought.
So for the recording, what he's suggesting is maybe use the setter for validation. It's computed, But the computing part of it is simply, do I let the value come through, right? Suppose you could use this as a bypass, but they have that functionality built in, you're right, with will set and did set. Do have that validation stuff built in, so that's probably a better way to do it. Could you use this for that? Maybe.
Can a getter or setter have parameters besides the value?
Can they have parameters?
No, I don't think so.
I don't think so, because it kind of bypasses what get and set do. Get gets applied whenever you use it on the right-hand side of an equation, and set. And so that's maybe another reason where methods come in handy. Maybe that's kind of what you're leading up to, is if I want to supply parameters, then I need a method. But typically when I call a method that's embedded inside of a class, it's using values that are already inside the class. And they don't have parameters. The ones I've dreamed up so far don't have parameters. And so it's not always the case, but you're right. That would be a significant difference here. My computed property cannot have parameters where a function could. So let's do an example here. In my first name, last name, what might I want to compute?
Full name?
Full name. Okay, so I'm going to create a, can it be a let? It's a computed property. Check my syntax, has a var in front, right? Yeah.
Something the letter needed to try to have a set.
Pardon me?
I just tried it with a var with no set.
Good point. No set and no get. If you don't have a setter and you're just defining a getter, you don't have to do anything here. You don't have to say that here's my getter function. You know, because there's no setter, you can even leave the get out altogether and simply say return first name concatenated with a space, concatenated with the last name. So you don't have to use the get keyword if all you're doing is providing a get feature. So again, this looks an awful lot like a method to me. When I use it, and where did I put that? Which class? I forgot. Student, right? No problem. Now, if I decided instead, and this is interesting, I'm not sure I can do this, but let's give it a shot. What if I create a function? We didn't talk too much about functions in the last unit. You get a chance to use them a little bit in this unit. If I define a function just with func, okay, and then its name, can I call it full name? Be interesting. What do I send it? Nothing. What does it return to me? A string.
I think they need to rename the function because they don't allow functions to have the same name.
Let's find out. You must be typing faster than I am, right? Invalid redeclaration. Okay, so I'll call this func full name.
I wonder if you could even just return the full name variable.
Interesting. Probably could. That seems redundant to have a function that returns the computed property. But can you use this in your equations? Absolutely. You can use that later on in your equation. So just to make things a little more distinguished here, flip them around. But things will be a little bit different when I use it. When you call a function, you must provide the parentheses, even if there's no parameters. So the difference between the method defined, and in the book they even mentioned that methods and functions are basically the same thing, except a method is inside of a class. Back to terminology, right? It's the difference between a function and a method. Methods inside a class. So the difference between a computed property, properties don't have parentheses. You don't put parentheses on. And a function or a method is you put parentheses on. But processing-wise, functionality-wise, inside, they're pretty much the same.
But you couldn't define a setter. I mean, to do that, you'd have to create a separate function. I mean, I don't know if you
Right, so now what he's suggesting is that I could create a function here, or pardon me, a setter inside of here, which means I have to get a little more complicated if check my syntax. Get curly brackets, okay. So this is get curly brackets. Why did the end key go to the end of the document? It's annoying. And then a setter. Setter with what though? Now if I give it a string, right, what he's suggesting is to give it a string, and then I have to take it apart and assign a first and a last name. But how do I know what came in? I believe it has a variable called new value. Okay. So maybe one of the first things I want is to find out the location of the space in the name. Now this is assuming somebody doesn't have, or we could search for the last space. I'm not sure if I know how to do that off the top of my head. I'm embarrassing myself in the recording. Maybe I should make that a ticket for your homework assignment. Write the setter that takes the full name. So what I want to do is something like this. Adam.fullname equals that. Anything for that matter. And then what the setter would do was take it apart. So the first thing I would have to know if I wanted to make this really functional is where's the last space. So if we have Bobby, Sue, Ann, Smith, there's lots of spaces in the Bobby, Sue, Ann. I don't want to use Bobby as the first name and then the Sue, Ann, Smith as the last name. I have to find the last space. What if you got somebody with a space in their last name? Let's figure that out some other day. But, so I need the space, a variable space location, and that's going to be equal to the new value. Notice that new value is available to you. It's built in.
You can change the name of that too if you want.
You can put it in parentheses, right? So if I want to change the name of this, then up here for full name, I put it in parentheses. Is that where it goes?
Right after the set.
Or just go, okay, so it would go right here. Okay, so I could say full name and then change this to full name. But now I need some string processing. Was that in my notes? It's probably in the recording. I have to go back to the other notes. But this is the process of learning a new language, which is why I find this so intriguing in this class. Is okay, now, oh man, now I need my string functions. Well, that's back in Unit 2, and I don't even remember how many of those I had. String processing is empty, toInt, has suffix, has prefix, count elements, and there we quit.
Components separated by string.
That's if we want to split it.
Is that what I'm searching for?
That's what.
Swift
that's the
component.
it's dot components separated by a string.
Okay.
So that will give you that.
All right, so he's just helping me out here. So is equal to full name dot components separated by string.
That's if you want to split the string, but not
Yeah.
if you want.
Yeah, but that's not bad because that's giving me an array of strings, and now I can now assume the last name is in the last index, right? So that's not bad. So let's use that.
Maybe.
separated by string where my separator is a quote, or space, excuse me. And there we go. There's my pieces parts.
As long as you don't put 2 spaces in there.
Well, if I do put 2 spaces in, then I have a different issue. Okay, so let's assume that it's Adam Joe.
The last name is the last item, and the first name is the concatenation of all the others.
Okay, so here's the split. Okay, and now I need to know the last index. So that's the count. No, not really. I guess it could be. Variable last index equals space. Actually, space loc is a bad idea. Let's call it name parts. Name parts dot count -1. Right? That's going to be the last index in my array. So last name, and I probably could have saved myself a little bit of grief, but I think I need this index more than once. Last name is equal to name parts sub last index. And what did it find? What the heck is that? That's the last index, but maybe I have to go to my results to see it. Where's my little icons? Oh, I'm too far up. I need to be down lower. Okay, and now I'm kind of eyeballing it here. And now can I use a for in loop? Only if I use a range. So if you like for in loops, for I in 0 dot dot. Is it less than? Brittany, you're my expert on that one, right? Less than last index. No. Yes. I don't want to include the last index because I've assumed that's my last name. Can I do that? Sure, why not? Just instead of creating a temporary variable, stick all these together, I'll just build my first name as I go. But if I do that, where do I put the space?
Problem is you'll end up with 1 extra at the end.
Yeah. But then we could use the trim function and trim that off, right? Okay. My problem is, how do I know how many names there are and how many spaces to put in? And the first name shouldn't have a space at the end.
Let's go first.
Here's how to do it.
Can-
First name equals name part sub 0.
plus
Up
space.
here,
Yeah. Plus 0.
and then start this at 1.
Right, and insert a space.
I like it. That's good.
Oh, nice.
Okay. And then if there's more, because what if last index is 1? Then this fails immediately. Let's check out any other for loop. Okay. If this doesn't have the right number of names, and if there's only one first name, the for loop never executes. First name plus equals name parts sub I.
A space plus name.
Thank you.
Plus I.
Why wouldn't you put the space after the name parts?
Because then you end up.
Because then I get one at the end always, and I don't want that. And I could strip it off using trim. That was my initial idea.
But not if you just add the last name. Oh, I see what you're saying.
Because I'd have to put it here, right?
Yeah.
And then if there is no loop here, then I got that extra space. And that's what I'm trying to avoid. So this was a good way to do that. The other way is just do all and then do a trim. Because I think there was a trim function that would just wipe the space off the end. Either way. So let's see how that works. And then down here, student ID, first name. Where'd my little icons go?
Try clicking on the left side of it, come back to it.
Any errors? I don't think so. There it went. Looks good. Now let's just do the test. What happens if I have a simple one? They click somewhere to make it work. I have no idea. There it goes. Seems to work. No extra spaces. So that's pretty slick. So there's a reason. There's an example. I don't know if it's a good one.
If you change the name, full name to something without spaces, I get it.
What?
I changed the name to just a single word and I got errors.
Well, then you get to deal with that. Now, if you put a single word in here, you know, I'd love to go by Volker, but America makes me put my last name on. And I'm not a soccer star, so it doesn't work. But yeah, if you put a single word in there, you're right. But why are you making a full name with just one word? Because that's not the way we think of it in most cases. If you want to deal with that, then you'd have to you'd throw an if statement in here or something, or go back to the other loop and say start at 0. And if the last index is 0, then it would never go through it at all. So the other one might work a little better there, but then you got to deal with the spaces. So there's an example of a computed property where we changed it. And it's not bad. What you would probably end up doing using other languages is having 2 methods, right? One to say set name, and you send in a full name and it takes it apart and sets the individual members in one method, and then another one called get full name that then takes it apart. Or sticks it together, I'm sorry. What we're doing here with the full name is putting it together and then taking it apart. And that's an interesting example. Thanks for picking up the student example, and thanks for telling me we could do it the other way around. So that's interesting. I like that.
I was just trying to figure out how to implode the array, because you could.
Implode as in this exploded it, right? Made it component parts, and then how do you implode it? Is there a way?
Because you can do your name parts that remove last, so you don't even have to worry about the last one there.
Right?
And then if you could just implode it with the space, that'd be.
Haven't found that yet.
Yeah.
Okay, but what he's basically saying is instead of using these for loops, and you guys are finding great ways. You notice that the language seems to be removing all requirements for for loops. Everything I used to do with a for loop like this, stick a bunch of names together, is now done by imploding an array, take an array and turn it into one object. I'll bet you could do the, what's it called? Reading. What do I do with arrays to turn them into a single value? I forget.
Explode?
No, reduce. I bet you could reduce it.
Oh, yeah. That's not a bad.
Shall we try?
Yeah. I gotta go over.
Go ahead. We're having too much fun. I was getting ready to let you go, but Adam brought up another, let's do it this way. Okay, so what you now want to do is say name parts dot remove last. Does that need to put it somewhere? No.
No.
Okay, so now all I've got left, it's removed the Holte there, the last version of it. And now I want to, first of all, come down here and put the Joe back in. And then in here, say that first name equals name parts dot reduce, where the initial value is an empty string. And then for each one, what do we want to do? We want to take the 0, concatenate the 1.
You gotta add a space too.
Syntax error. Anonymous closure argument not contained in a closure.
You need the curly brackets around it.
Around this, thank you. It's Reen's fault for showing me min without the curly brackets.
Got it.
Looks like it.
Let's get my last name. Get the last name. Or first name, I guess. That will.
So much for loops. Who needs them? But this reduce, once you get used to it, that's your implode. You said that, and my thought, well, wait a minute, we're taking an array and squishing it down into a single value. That's reduce. And that's part of what I wanted to share with you, and I will share with you next time, is some of the techniques that you came up with as a group to solve that first assignment that I gave you. I probably got 10 different solutions. I know I got 10 different solutions. But in each one of them, there was something I went, oh, that's pretty cool, or that's pretty cool, and that's pretty cool. And I almost stole, Paul, was it yours? I almost stole yours and then thought, no, I don't like that. Because I think, didn't you create the random number generator that accepted a range? Was that you?
Yep.
Yep. And so he called it get random, and he sent it a range. I want our numbers between the range of 0 to 100. I said, that's pretty cool. Except when you send the range, the range is just defined with a min and a max. All right. But is a range more effective than two integers? Especially since you're really only using the integers at both ends anyways, right?
No, it was 2 integers.
But yeah, the range is defined with two integers. But what instead of sending in a range, you just sent in two integers, two parameters instead of one, that are integers versus a range that contains two integers, probably a horse apiece. My first thought, that's pretty cool. It kind of gives you the idea of I want random numbers in this range, 0 to 100. So it reads well, but really all you're doing is all you used was the 0 and the 100 and went from there. And so I struggled with it a little bit, whether I liked yours better than mine. Initially my thought was, yeah, I liked his better, I'm going to use that. And then I said, yeah, maybe not. Not that yours is it's just not that much different. So there's a lot of different techniques that I saw, and I'll try to get those together for next time. You've got a pretty good start here if you want to get started on Unit 3's assignment. You've got a nice background here. There's still a few things to talk about, but most of what you need to do that assignment is here.